Hi students, this is Ms. Oberly with lesson 7-4, parallel lines and proportions. By the end of this lesson, you will be able to use proportional parts within similar triangles to find unknowns. Let's start with our first theorem. If a line is parallel to one side of the triangle and it intersects the other two sides, then it divides the sides into segments of proportional lengths. So again, if these sides are parallel, then we know we can say AB is to BC as AE is to ED. So let's use that. In triangle PQR, ST is parallel to QR. If PT is 7.5, and TQ is 3, and SR is 2.5, they want us to find PS. So we're going to use this exact same setup where we say this part is to this part as this part is to this part. All right, let's do it. So we're going to say PS is to SR as PT is to QT. So can you fill in those parts? We don't know what PS is. And then you know how to solve a proportion. Are you getting a final answer of 6.25? You should be. Let's go on to example 2. Actually, before we do that, the opposite is true. So if we know that AE is to EB as CD is to DB, then we know these line segments must be parallel. So let's fill in what we know. In this case, EH is 3, HF is 9, DG is 1/3 the length of GF. So we could say that this is 1 and this is 3. Now if we set up this proportion and they are equal, we then know that DE is to GF. And actually right now I'm guessing most of you are seeing 1/3 is the same as 3/9 reduced, so we know these line segments must be parallel. If you need more of an explanation, there is one here. Triangle mid-segment theorem. So a mid-segment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. Does this remind you of any other theorem we've talked about? Maybe the trapezoid theorem? So if J and K are midpoints of FH and HG respectively, then JK is parallel to FG, and JK equals 1/2, so JK is 1/2 of FG. Well, let's see if we can apply this, given this picture. First, we're going to find XZ, so this segment right here. Well, I want to focus on this one because I know that XY and XZ are mid-segments. So if we know this is 13, do we know how long this is going to be using that mid-segment theorem? Well, yeah, this is going to be 1/2 of this length. So we're going to use the mid-segment theorem, 1/2 of 13, which is 6.5. Part B, let's find ST, switch colors. So ST is this segment right here, and this segment is related to this segment right here. And we know that this is 7, so can we find that using the mid-segment theorem? Well, we're just going to multiply by 2 and find out that ST is 14. Finally, what about finding the angle of measure of angle RYX? RYX, so that's right here. I think it might help to erase what I have here so you can see it better. All right, let's go back and switch colors. Yeah, one more time. So this angle is the one we're trying to find. Well, let's focus on, do we have anything that we know? Well, we have parallel lines. Remember, we just figured that out with the mid-segment theorem. Cut by a transversal. And if we have parallel lines cut by a transversal, do we know how these two angles should be related? Well, yes, they're alternate interior angles, so they should be the same measure.